Okay, let's look at an example. So we just do the same thing we always do. We extract the information from the question first. So it says a radioactive substance has a half-life of 22 hours. If it initially has 22 by 10 to the 8 unstable nuclei, so that's our initial value, so it's N0. How many unstable nuclei will be there after a time of 10 hours? Okay, now we're going to use this equation that links all them together. Now, we have the decay constant in there, but we're not given the decay constant here. So in fact, the first thing we have to do is use this equation to get our decay constant. So if I put in T in hours, I can do that, and I'm going to do that to begin with here. And that will give me a decay constant then that is not in seconds. So 0.0315 per hour. Okay. Now that's okay because when I use this equation then in some of my values, n equals n naught 22 by 10 to the 8 e to the minus lambda, which is 0.0315 per hours multiplied by 22. Sorry, it's 10 hours, isn't it? It's t. I'm putting the half-life there. 10 hours. Okay. The key thing about the indice here is it should not have a unit. So if this is per hour and this is hour, they cancel out and that's fine. If this is per second and this is seconds, that's fine, but you can't mix and match them. Okay, so if t was in seconds, I would have to convert this to per hour. And then it's just a matter of typing that correctly into my calculator. So if you just give me a little second. So we have the indice there. I'll just write through the steps to make sure it's very clear what order you do this in. Will be minus 0.315. When I type that into my calculator, so E, the biggest mistake most people make when doing this is they forget the minus sign in there. So we need to be careful with that. And my calculator does not seem to be allowing me to do this correctly. That's better. So minus 0.315, which is, okay, calculator's playing up. Give me 1 wee second. Power of minus 0.315. And that gives me 0.7298, which gives us then 16.1 by 10 to the 8 unstable nuclei. So it doesn't really have a unit there. Always have an idea of what your answer should roughly be. What I'd be looking at here is we start off at 22 by 10 to the 8, half-life at 22 hours. So after 22 hours, that should be down to 11. So after 10, it being down to 16 sounds about right. Okay. The second question then, what will the activity be after 10 hours? Now, what I could do is I could use A equals A naught e to the minus lambda t. I already have lambda. We know t is 10. I would need to work out A naught, put it all into that equation to work out A. I could do it that way, but it's much longer than is necessary. The other equation we have is that A equals lambda n. Like I said, we've got a minus in there. We tend to ignore that. Okay, so don't worry too much about the minus. However, this activity that I've worked out is in per hours. That means my activity, or sorry, the decay constant over here is per hours, which means my activity will be per hour. That's not the unit we use. We tend to use becquerels, which is per second. So I'm going to work out what lambda is in seconds, first of all. To make sure you don't make mistakes, I would tend to start again with this. And I would do, my time is 22, but that's hours, so I need to multiply that by 60 and multiply that by 60. If you start trying to change per hours into per seconds, because it's per hour and per second, rather than changing from hours to seconds, you usually multiply by 60 and multiply by 60. You have to divide by 60 and divide by 60. It's sometimes easier going back, changing the time into seconds, and then using this equation again to get a value. So we will get 0.693 divided by 22 times 60 times 60. And that gives me 8.75 by 10 to the minus 1, 2, 3, 4, 5, 6. And that is then per second. Okay. Once I've done this, then I can put this into my equation. So we have A equals lambda n. A equals 8.75 by 10 to the minus 6 multiplied by the n. Remember, we're looking for the activity after 10 hours, so we have to use the number of unstable nuclei after 10 hours, which is what we worked out here. So that would be 16.1 by 10 to the 8, wasn't it? Which will give me an activity of I'm using my phone calculator, so it's not just as good. So 16.1 by 10 to the power of 8, close brackets, and that should give me 14,087.5 becquerels. Okay,